Alright, so this is the second page of the final review packet, and basically 13 through 15 they're asking us to go ahead and solve for x, and they tell us something in each of these instructions. What they're telling us is they're telling us that R and T are parallel lines. So I can go ahead and use that information, and I'll just go ahead and mark them here. That way I can be reminded that they're parallel, even though they might not necessarily look parallel. They are, because the instructions told me they are. So what can I assume? Well, I can assume that 105 here is going to play a role, and x plus 15 here is going to equal a role. And I can also say that this angle and the 105 are what we call corresponding angles. And because they're corresponding, that means that they are congruent, meaning this angle here being 105 will be replicated on this side being 105 as well. Now, the way this 105 is going to play a role is when it interacts with this x plus 15, they're going to be called what we call supplementary angles, meaning if I add them together, I will obtain 180 degrees. So all I have to do is I just have to go ahead and combine them out. X plus 115 is equal to 180, and then just subtract 115 from both sides. So what I get is I get x equaling, looks like 100 is going to cancel each other out. 80 minus 15 is 65. Now from here, x only equals 65, but if they wanted me to measure the angle itself, that means that the angle measure is 65 plus 15, which is going to be 80 degrees. All right, so just keep that in mind. In case they decide to ask you for both, we can be assured of both. All right, so let me move on to the next section. I'll find another problem. Give me a second. Alright, here comes the next problem, and holy guacamole, there's a lot of stuff to solve here. So, let's just take it one thing at a time. They give us enough information to solve for all these things, so let's just take it one thing at a time. So what do we know so far? I'm guessing because this is 57 degrees right here, this K will also be 57 degrees, right? So I'm going to write that down. So K equals 57 degrees. Right? What else can we figure out so far? Well, I know that the H angle, right, is going to be 180 minus 57. So I know that H is equal to 180 minus 57, which is going to be 123 right here. And again, how do I know that? These guys are a linear pair. Okay? So from here, M is vertical to H. So hopefully it makes sense then that M is also 123 degrees. Okay, so now, what else can we figure out? Well, I know that 81 is going to be down here. Q is a corresponding angle to this 81. So Q is going to be 81 degrees, which makes G 81 degrees also. Now, because P is supplementary to this line, that means that P and 81 will have to sum up to be 180, right? So I know that P plus 81 is equal to 180. So I know that P is equal to 99. 99 here. That means that F, because of vertical angles, is going to be 99 also. So let me just summarize this real quick. We've got the vertical angles here, linear pairs allow for this to happen, and then more vertical angle work on this side. Okay, so what else do we know so far? Well, I know that R must equal 57 degrees. How do I know? Well, you see how this K is 57 degrees, right? This R has to be 57 degrees because of alternate interior angles. All right, so make sure we keep that one in mind. In this case also, because I know R and I know this angle being 81, these three angles, R, S, and 81, create an entire linear pair, making 57, which is R, plus S, which is S, and then plus 81 will have to equal 180 degrees. So after combining the like terms and subtracting from either side, S ends up becoming 42. So again, there's just a lot of mumbo-jumbo going on here. Last but not least, we've got this line here, 17, on 17. We know that R and V are a linear pair, so I just need to do 180 minus 57 to get V. So that will get me 123 degrees here, and I know that V and U are also a linear pair, so I can say 123 plus U equals 180. That makes U 57 degrees. That's a lot of work. So basically, the main things that I rested my laurels on for this problem were some vertical angles, alternate interiors, and linear pairs. That was basically the crux of 17. You might need to see this problem again to see the reasoning behind each angle. So if you need to, rewind, click back, and then check it out. I said the reasons for each angle when I put these angle values in, so go and check it out again. I will be back with the next problem. So with 19 through 23, I'm going to try to determine if these numbers can qualify as a triangle. Now, the biggest thing about this is that the third side needs to be smaller than the sum of the other two sides, but larger than the difference of the other two sides. That's too many words for you. Let me go ahead and demonstrate. When I say the third side must be smaller than the sum of the other two, in this particular example, that means that 5 must be less than 3 plus 4. Is that true? Well, yes, it is. It's true. So far, we're doing okay. Now, in this case, 5 also has to be larger than the difference between the two. So 4 minus 3. Is that true? That is true. So it looks like we're doing pretty good. Triangle is possible. Now, you would try this for other combinations. If the other combinations, one of them didn't work, then the triangle would not be possible. But for now, this is true. In fact, if you guys know your Pythagorean triangles pretty quickly, you'll know that it's actually what we call a Pythagorean triple. All right? I'll be back in a flash with the next problem. So in number 20, remember how we just talked about how the sum of the sides here must be larger than the third side? Clearly, this one is not going to work, because if I look at 8's relationship with 2 plus 4, right, 8 is larger, which means this triangle is not possible. Okay? 8 would have to be smaller than this sum in order for the triangle to be possible. So, unfortunately, this one's just not going to work. Once we see a disqualifying quality, the triangle is done, which is great for us. So, I'll move on to the next section in just a second. In the next section, we are going to be asked to simplify radicals completely, leaving them in the simplest radical form. So the first problem, 24, was actually pretty easy because it's the square root of 400, which is a perfect square. But when we have problems like this that are not perfect squares, how do we break them apart? Well, it's been a while since we've done this, but usually what I look for is I look for two numbers that multiply to 800, where one of them is a perfect square and the other one is not. This one is relatively obvious. It's rad 400 and rad 2. And again, I really want to make sure we put those radicals in there, that way we know what's happening. The square root of 400, as we saw in the last problem, hopefully, will become straight up 20, and then rad 2 will come along in sequence. So I know there are a bunch of different methods. When numbers start getting higher like this, I think the multiple division by 2 is less helpful. So knowing your square roots quickly is definitely going to be an advantage in this problem. Moving on to number 27, what we have is we have the square root of 72. And with 72, there are a few different methods you could do. You could do the most obvious one, which is going to be root 9 and root 8. This is a really good combo. And so because root 9 ends up becoming 3, and you end up with 3 rad 8. The problem with this is that a lot of people are going to think that they're done right here. But they're not done, because the square root of 8 can also be broken apart into the square root of 4 and the square root of 2. The square root of 4 becomes 2, and don't forget that that 2 interacts with that 3 to become 6, and then the square root of 2 will come along for the ride. Now again, I talked about rad 72 being broken apart by rad 9 and rad 8, and that's a good combination. But as always, we're looking for the gooder combination. So I think if you can see this, 36 and 2 underneath the square roots is going to be your better option, because the square root of 36 is straight up 6, and then you end up in the same position with a lot more cleanness. So it's up to you, depending on where you feel comfortable. that's going to be where you're at. But that's simplifying radicals as best we can. Okay, so let's go to the next section. And now we are working in complex numbers. We have recently learned I, which is an imaginary number, used so that we can now take square roots of negative values. So, imaginary numbers, we are now becoming electrical engineers at Chuck E. Cheese. What we're going to do is I'm going to break this apart like I normally do, except I know 4 is a perfect square, but I'll go ahead and call it the square root of 4 times the square root of negative 1. We know that the square root of 4 is going to be 2. And the square root of negative 1 is simply I. And that's as far as you can go with that problem. Next problem here, with 32. We have learned recently that the square root of negative 1 is I, meaning if I was to get the square root out of here, I could square both sides and call I squared to be negative 1. And that's going to be really the crux of this problem here. I know that 2i squared is really 2 times negative 1 because, as I just showed you, I squared is negative 1. So this ends up becoming negative 2. And there you are. You are successfully an electromagnetic, mechanical, technical, service diagnostic engineer at Chuck E. Cheese. We'll see you in the next section. And welcome to the last problem on this page. So, we are just going to solve for x, and that's all we're really being asked to do. So if I look at these two angles right here, our good old buddy vertical angles make their triumphant return. Now, the idea behind vertical angles is that they are congruent. So to solve for x, I literally set the angles, equal to each other, and then go and solve for x. So I think I'm going to go ahead and add 38 to both sides. So I get 5x plus 48 is equal to 7x. If I subtract 5x from both sides, I will get 48 is equal to 2x. And the hardest part of this problem is knowing what 48 divided by 2 is. I believe it is 24. And that should be good. Let's go and take a look at problem number 36, where I'm solving for x here on the outside of this triangle. In fact, you could consider x to be an exterior angle of this triangle. And knowing that, we can use the triangle exterior angle sum theorem, which basically says that the measure of the outside angle is equal to the sum of the two remote interior angles. They're remote because they're away from. Okay? So I literally could say x equals 93 plus 36 and get 129, and that would really be the end of the problem. However, it's not realistic for all of us to remember that theorem. So what if we didn't know that off the top of our heads and we're on the final and we just forgot? Well, what we could do instead is we could go back to basics and what we know. So I could call this angle here, I'll go and call him A. I should know that all three angles should add up to 180, right? So I know that A plus 93 plus 36 should equal 180, right? Well, I know that A plus, and I've already added these two guys together to get 129, and that's going to equal 180. So I know that A is equal to 51 degrees. If I subtract 129 from both sides, I'll get A to be 51. So that's what this is. So then I can use my linear pair idea here to say that x, which is my angle that I'm really solving for, plus 51 is equal to 180. If I subtract 51 from both sides, let me scroll down. If I subtract 51 from either side, I should end up with x equals 129. Either way I cut it. Okay? So that does it for this page. I will be back on the next page, and we will see you then.